Hello, good morning. Determination of arsenic. There are several methods for analysis of arsenic in drinking water. Atomic absorption spectroscopy with hydride generator system, with flame, graphite furnace for atomization, ASGF. Inductively coupled plasma with atomic emission spectroscopy, ICP-AES, with mass spectroscopy, atomic fluorescence spectroscopy, AFS, anodic striping voltammetry, ASB, spectrophotometry, inductively coupled plasma, ICP is a high temperature plasma ionized gas generated by electromagnetic induction using a radio frequency coil. It is primarily used as a source of atomizing and ionizing elements for spectroscopic analysis. Basic principle, plasma generation. An inert gas, usually argon, is ionized by a high-frequency radio frequency field. The resulting plasma reaches temperature of 6,000 to 10,000 kilovolt, sufficient to atomize most elements. Sample introduction. The sample is nebulized, converted to aerosol, and carried into the plasma by argon gas. Atomization and ionization. The high energy of the plasma breaks the sample down into free atoms and ions. Emission and detection. Atoms and ions emit characteristic light emission. As they return to lower energy state, the emitted light is measured to determine the type and concentration of elements. Schematic of an inductively coupled plasma source, gas inlet, dielectric plasma chamber, source electrode, extraction electrode, split Faraday seal, induction field. Instrumentation of ICP, sample preparation, sample introduction, ion source, vacuum system, focus and separate, mass filter, detector, data analysis. ICP with mass spectroscopy, the high temperature plasma atomizes and ionizes the sample, generating ions, which are then extracted through the interference region and into a set of electrostatic lanes called the ion optics. The ion optics focus and guides the ion beam into quadrupole mass analyzer. ICP-AS, the main difference between AS and ICP is that AS measures sequentially while ICP measures simultaneously. For each element you analyze in AS, the instrument runs the test separately and each hollow cathode lamp emits its light and absorption is measured for a single element in each run. ICP with atomic emission spectroscopy, inductively coupled plasma atomic emission spectroscopy, ICP-AS, also known as inductively coupled plasma optical emission spectroscopy, is a powerful analytical technique used to measure, determine the elemental composition of a sample. It uses a high temperature plasma to excite atoms and measure the emitted light, providing both qualitative and quantitative information about the elements present. Atomic fluorescence spectroscopy, anodic striping, voltammetry, and spectrophotometry. Atomic fluorescence spectroscopy is the emission of radiation energy in the UV visible region from gas phase atoms that have been excited to higher energy levels by absorption of radiant energy. Usually, a flame is used to obtain the atom in a gaseous state. It is a radiative emission process that proceeds from lowest singlet to the singlet ground state. Jablonski diagram, phosphorescence, fluorescence, intersystem, ground state to S1 and come back to ground state fluorescence and intersystem phosphorescence solution mist evaporation solid vaporization dissociation and excited to external source emission of light. Okay. Jablonski diagram. The excitation from ground state to S1 and come back to ground state is fluorescence and intersystem crossing S1 to T1 and that is the intersystem crossing and T1 to ground state transmission state. Ground state is called phosphorescence. Downward arrow start fluorescence, downward arrow non-radiative relaxation, internal conversion, S1 T1 intersystem crossing, and down to T1 phosphorescence. Solution mist, evaporation, solid, vaporization, gas, dissociation, excitation by the external source of radiation, emission of light, fluorescence. N1 over N0 equal to G1 over G0, E minus delta E over KT. N1 number of atoms in excited state, N0 number of ground state atoms, G1 over G0 ratio of statistical weights per ground and excited states, delta E energy of excitation, K the Boltzmann constant, T temperature in kelvins. Absorption and emission. Instrumentation of atomic fluorescence spectroscopy, line source, flame, monochromator, detector, amplifier, readout, electrochemical atomizer. The above listed analytical methods are base and sensitive. Hydride generator systems is the most commonly used method, but requires skillful manpower with expensive instrument. Also, the ICP, mass spectroscopy, atomic emission spectroscopy, atomic flame spectroscopy, ASV, AS, gas chromatography provides accurate and more sensitive but not affordable in case of Nepal due to expensive and highly skilled manpower. Among the following methods are used in case of our country of Nepal. Field kit method. It is used for the analysis of arsenic in environmental sample of water but not precise, even though in case of Nepal it is the best option because in Nepal there are only a few of laboratories with competent personnel and environments. Two Nepali kits, Anfo kit and modified AN kit is available in Nepal. First of all, hydrogen sulfide is oxidized to sulfate and the oxidizing environment is neutralized to remove interference. Then by the help of powdered zinc on acetic medium, inorganic arsenic is reduced to arsenine gas. Arsenic gas so produced reacts with mercury bromide impregnated in paper to give a measurable yellow color. Acetic oxide, zinc, hydrochloric acid, and this reaction in place of hydrochloric acid, sulfamic acid is used as the latter is solid and portable. In this method, sulfide, if present in samples, are reduced to hydrogen sulfide gas, which reacts with mercury bromide to give yellow color. Hence, sulfide should be removed. The kit method for determination of arsenic does not give exact concentration of the arsenic in groundwater, rather gives the range of concentration. The color developed in the paper is compared with color scale to determine a range of arsenic level in water. Determination of arsenic in water by silver dithylcarbamate. Among these methods, the SDDC spectroscopic methods for determination in arsenic in water is quite simple, standard, and inexpensive. First of all, the arsenide is converted into arsenic state, third state, and this is reduced by zinc is acid solution to arsenine, which is absorbed by SDDC solution to form red complex. If stibnum present in 5 times excess, then arsenic, then it interferes by forming the stibine red complex. Other metals such as copper, chromium, cobalt, nickel, silver ions also interfere. But these are present in very small amount and do not significantly affect the value of observance. Switch on the spectrophotometer and let it stabilize for the least to 20 minutes. Set spectrophotometer in observance mode and set wavelength 570 nanometer. Pipette 50 ml of well-mixed sample into a 250 ml beaker. Add 1.5 ml conch sulfuric acid and 2.5 ml nitric acid and digest until the white films commence. Cool and wash the interior wall of the beaker with little distilled water and transfer to 50 ml of volumetric flask and dilute up to mark by deionized water. Transfer to 150 ml of arsenine generator. Add 2 ml of hydrochloric acid, 2 ml 20% potassium iodide, 0.5 ml 40% stannous chloride solution with mixing after each addition. Do this process for all the standards and sample, wait 10 minutes for complete reduction of arsenic fifth to arsenic third. Impregnate the glass wool with an acetate solution and put into a cruber. Sorry. Okay. Impregnate the glass wools with lead acetate solution and put into the scrubber. Connect the arsenic generator scrubber and observer assembly. Make airtight pipette 4 ml of SDDC reagent in observer tube. Add 3 grams of zinc to the generator and immediately replace the stopper. Wait 30 minutes for complete reaction. Pour the solution from the observer into cuvette and measure the absorbance at 535 nanometer of all the samples and standard samples. Prepare the calibration curve by taking the suitable volumes of standard arsenic solution and same procedure as for the sample. AS method with hydride generator. Elements like arsenic, stibnum, selenium, etc. are difficult to analyze by flame AS because it is difficult to reduce compounds of these elements to the gaseous atomic state. This method is often preferred than the electrothermal atomization methods for determination of arsenic, stibnum, and selenium. In this method, compounds of these elements are converted to their volatile hydrides by the use of sodium borohydride as reducing agent. Okay, arsenic into arsenide. In this way, we can determine the arsenic in water by the SDDC. Okay, it's all about determination of arsenic by different methods. AS, ICP, AFS, anodic starving voltammetry, ASV, spectrophotometry. Thanks for watching and request you all like, comment, share, and subscribe. Thank you for patience. That's now. Bye-bye. See you again.